So hello students, I welcome you all to this lecture on the continuation of thermodynamics for class 12 physics class. So we have already discussed about the work, that how to calculate work. So today we will be going to discuss numericals on work, and then we will be going to discuss the first law of thermodynamics. So in the last lecture we have discussed that work is nothing but P dV, or it is area under PV curve, and we have discussed sign convention, that work done on the system is taken to be negative and work done by the system is taken to be positive. So all these things you should remind or you should know while doing the numericals on work. And to learn this sign convention, I am again repeating that you can just look at this system where you are having a piston and gases, some gases there present inside this piston cylinder system. And so if you, let's say, apply some if you do some work and compress the gas, let's say from here to here, so new position for that is this. So before that it is V1 or V initial, I can say, and finally it becomes Vf. So delta V becomes Vf minus Vi, and because it's a compression, so due to that we know that Vi is greater than Vf, and so work done is P into delta V, where delta V is coming out to be negative, so we put minus sign here. And so from here you can learn that when you compress the gas, or the work done on the system is taken to be negative, and when work done by the system or work done by the gas, there is expansion. Due to this, final volume is greater than initial volume, and then the work done is positive. Okay, so let's do one numerical on it. So the numerical is like this. We are having a simple question. So you are having pressure volume curve where let's say this point is one, this point is 2, this point is 3, and this point is 4. So there is a process going on, and for that you are having a so the question is, the process is explained through PV diagram shown in figure. Find out the work. So let's call it as point A and call point B. Work done from A to B. Okay, so we need to find out the work done from A to B. So if you see that we need to find out the area under PV curve. So when I am saying area under PV curve, so it means to say that, just to make you remember. So when we look at the PV curve and we are having, let's say, some process, and so we need to find out the work done in this process. So we need to find out this area actually. So why I am saying this area, because work done is integration of P dV, and the area swept under this curve only will give the work. And how it is coming, because if you take this strip, let's say one strip dW, okay, and so pressure is P, so let's say P1, P2, P3 is going on along this line. So P dW1, dW2, so all these strips, let's say you are taking all these strips and you are integrating that, so that's you are getting the area under this curve. So okay, so you are taking this strip, so it is a simple rule of integration. So from here you should know that, do you think the area of which area we need to take if this curve is given to get out the work? So I have two areas, this area or maybe this area. So it is clear that when I have to find the work using this area method, we need to find out the area under PV curve in a way that the stripes are divided along V. So stripes are divided along V on a way, in a simple way, that you have to take dV, small dVs. So small dVs you cannot take along this horizontal axis, so we need to take along the vertical axis. So that's why we have to take, so the correct area to get out the work is this. Okay, because we are able to divide this dV strips here along this, and let's say it is at some pressure P. So pressure along dV, so dV, dV, P1, dV1, P2, dV2, and so making this area, we will going to get the area under this green region. The area of this green region will tell me the work done. Okay, so now let's find out the area under this region. So work is so let's call this AB and maybe CD to these points. So work is area of trapezoid. So it's a trapezoid where it is A, B, C, D. So if you don't know the how to calculate the area of trapezoid, I am telling you the simple way to find out that. So you have this triangle first. So you find out the area of this triangle and then add the area of this square, then you will get the area. So this width is, this is nothing but 1 and this is nothing but 2. So the area of this square is 1 into 2 plus area of this triangle, that is half. Base I know 2 and height I know, so this is the height, that is 2. So what I get is 2 plus 2, that is 4. I hope you are able to get this area. Okay, so area under this green curve is this. Apart, if you know the area of trapezoid is nothing but is half sum of non-parallel sides, sum of parallel sides into width between them. So that is 1 by 2. Sum of non-parallel sides is 1 into 3 into, so this 3 into, so sorry, I have to sum up this. So sum is this 3 plus, so this side I have to take and this side I have to take, plus 1 into 2. Into 2, so that is 4. So you can either use this formula or use this formula to get the correct work done. Okay, let's look at another question. So we are having this diagram where you have pressure this side. Now the axes are changed, so we have this kind of curve. To make it again clear. Okay, so this process, let's call it A, B, and, or I can say A, B, and C, like this way. So this point is given to me is 1. This point is 4. This point is 5, and this point is 3. So the question is, from the given figure, find out the work done first WAB, so from going A to B, WBC, WCA, and finally WABCA. Okay, so we need to find out these parts. Okay, so let's go one by one. So WAB we know, along the line, along the process AB, if you see, volume is constant, and hence it is a isochoric process. Because volume is itself constant, so dV is 0 at constant pressure, so that's why WAB is PdV, and there is no area swept under this curve. So along this line there is no area, so that's why PdV is 0. So WAV is 0. So that is 0. Second part is WBC. Okay, now we are having pressure constant, and volume is increasing from B to C, that means that there is an expansion and work is done by the gas. Therefore, work is taken comes out to be positive. So, we have P. So, we need to find out the area under, and going from process B to C, we have to find out this area, whole area of this rectangle. So, this we know that is 3, this we know that is 5. So, area comes out to be area WBC, area is 3, this is 3 into 5, that comes out to be 15. So, take this to be liter and this is in ATM. So, work done is 15 ATM liter, and sign is found to be positive because it is work done, it is in the process going from B to C, there is expansion, and due to that expansion the work is done by the gas. So, that is 15 ATM liter comes positive. You can also look just like you can take P Vf minus Vi. So, P we know at constant pressure, that is 5 into Vf, final volume is 4 minus 1, that is 3, that is 15. So, but if area is given, then it is good to go with this way. Okay. So, this is about the first two processes. Now, let us go C to A. So, W C to A. So, what is happening? Let us look what is happening C to A. So, from C to A, you will see volume is decreasing. So, volume is decreasing means there is a compression, and whatever the work you will get from this should be negative because there is a compression and there is work done on the gas, and according to our sign convention it should be negative. So, from C to A we need to find out the area under this curve. So, we need to find out the area under this curve from C to A. So, WC to A is area, green area, I can say green, and so we can get 1 by 2 sum of parallel sides. So, sum of parallel side is this. So, this is 3 and we know this is 5, and this height or the width between the parallel lines is 3. So, 1 by 2 into 3 plus 5, 3 plus 5 into 3, right, 3 plus 5 into 3. So, that is 412 ATM liter, but the sign taken to be negative. So, WCA comes out to be minus 12 ATM liter. So, this here we get work done from C to A is minus 12, it is 15, and work done in going so the total work we need to find out from A, B, C, A. So, A to B to C to A. So, it is nothing but WAB CA is WAB plus WBC plus WCA. So, WAB is 0 plus WBC is 15 plus WCA is minus 12. So, that comes out to be 3 ATM liter. So from this I would like to conclude that the work done, if you going along one cycle, it is not always 0, it can have some value, and that is the way we can say the work is dependent upon the path. So with this I would like to end this lecture. Thank you.